You can't do that unless you begin with the bad parts, which is the Columbia accident, which was a tragedy in a lot of ways. However, it also contributed to a sea change in the way we're doing things and where we're progressing right now. Programs like the space program, they are great projects because of the number of elements involved. And there's only 3 possible reasons to do these kinds of things, either money, ego, or war. And those are the general, I would like to believe that education is another one, but I have trouble grasping that one since we don't seem to put as much money into education as we do into these other things. But these kinds of projects take a lot of time, and invariably they kill people. And the Panama Canal, for example, took decades to complete. It cost over $7 billion and claimed 5,609 lives. And when you look at these projects and you ask yourself, were they worth it, only time can tell. Of course, you look at the Panama Canal and there's no question about it's worth it. So it's very hard to judge at the moment whether or not the Space Shuttle program is worth it. I hope in the next 2 lectures I'll help you answer that question. But again, starting with the bad parts, this is what we saw in February 2003 for the last launch of Columbia.
10, 9, 8, 7, we have a go. We are to start. 3, 2, 1. We have booster ignition and liftoff of Space Shuttle Columbia with a multitude of national and international space research experiments. Houston now controlling.
Okay. I like to show that because in all respects, both in the air and on the ground, this was an absolutely nominal launch with no apparent flaws in it. However, as all of us know, about 12 days later, on February 1st, shortly before 6 a.m., people photographing the landing of Columbia at first saw this, streaking west over Owens Valley, north of Big Pine, California, shortly before 6 a.m. And subsequent to that, this image, which was shown on all the televisions pretty much as it happened, showing the breakup of Columbia and its destruction. At this point in time, the people who are controlling that flight and speaking to the crew know pretty much what you know watching what you've been watching. There was data until the last second, and then there was this, and there was no data. And so you ask yourself, like, good grief, what's happened? And after the initial stunned silence, you try to determine what it is that happened. And this launches a process that has been used in many different arenas similar to this. The process is called a fault tree, and it's how you solve a destructive event like this, or attempt to solve it. It's very, very interesting, and you learn a lot from doing it. The fault tree is a top-down graphical deductive analysis. That's a lot of words, but in the end, it means the same thing as the Sherlock Holmes method. It takes an end point and asks what can cause this to happen. You use this process when there are large losses of life or very high risk, numerous possibilities as to what caused a mishap, complex systems, many of which can cause such an event to take place. This process works by taking the topmost end state. In this case, we have a lot of acronyms in NASA, as all of you know. LOCV, thankfully it's not used too much. It stands for loss of crew and vehicle.